This is a lesson 4.6 recording, Math 020 Pre-Algebra, taught at St. Louis Community College, recorded by Dr. Victoria Shearing. In lesson 4.6, we're going to add and subtract mixed numbers. There is only one objective for this lesson, that is, learn how to add or subtract mixed numbers. We're going to start with a picture representation of an example that would demonstrate the idea of adding and subtracting mixed numbers. Remember when we had to multiply or divide mixed numbers, we changed them into improper fractions and then we multiplied or divided. The reason why we did that is because we did not have to worry about the common denominator. When you add or subtract mixed numbers, there will be cases where you would have to come up with a common denominator. So using the first method that we used for multiplying or dividing mixed numbers will not necessarily work. So we're going to use a different method that will work for all cases. Okay, so let's take a look at what happens if we have to add 1 1/4 and 2 1/4. So both numbers have the whole parts and the fraction parts. So the 1 1/4, you have a whole part and then you have a quarter part. And the 2 1/4, you have two whole parts and you have 1/4 part. So just like we add the numbers, you can pictorially line them up. So you have 1 plus 2, which gives you 3, and then you have 2/4 that you have to add, all right? So you would have the 3 wholes and 2/4, okay? So you added the whole parts, you added the fraction parts, you got 3 2/4, and then you reduce 2/4 to 1/2. And you can see it even on the picture, 2/4 is the same as 1/2. So from this very short example, we are ready to formalize the rule how to add or subtract mixed numbers. Step 1, you're going to add whole parts. Step 2, you're going to add fraction parts. And then step 3, you're going to simplify if possible. One thing that you need to note, that just like with whole numbers, when adding or subtracting fraction parts, you may have to carry over or borrow from the whole part. So sometimes you may not have enough digits, or have an improper fraction. So we'll talk about it when we do the examples. Okay. All right, so let's look at our examples. Here we have, in example number 1, you have 1 and 3/20. We're adding 17 and 7/20. Okay, so you have whole parts, 1 and 17, and you have a fraction part, which is 3/20 and 7/20. So we're going to add them separately. Okay, so we do 1 plus 17 equals 18. 3/20 plus 7/20 gives you 10/20, and we reduce that to 1/2. So now let's assemble our number back again. So the answer would be 18 for the whole part and 1/2 for the fractional part. This is your official answer for this problem. Okay. Problem number 2 gets a little bit more challenging because at a quick glance, I have the 21 and 2/9, and I have 10 and 1/3. So I can still add the whole parts, but adding the fraction parts, I would have to find the common denominator, go through the whole process, and then so finding fractional part answer is going to take a little bit of work. Okay, so let's go ahead and do 21 plus 10 gives you 31. Okay, so that's done. And now we're going to add 2 over 9 plus 1 over 3. So the LCD for these two, so step number 1, LCD for these two is 9. Okay, so step number 2, my 2 over 9 stays the same because the old denominator was 9 and the new denominator is 9. So I don't need to change 2 over 9. But 1 over 3 needs to be changed to reflect the new denominator of 9. So 3 times 3 is 9, so I need to multiply by 3, so it's going to be 3 over 9. So the fractional parts that I am adding are 2, 9, and 3 over 9. So let's go to my step number 3. So step number 3 is 2 over 9 plus 3 over 9, and I have 5 over 9. So at this point, I have the whole part. My whole part was 31. My fractional part is 5 over 9. And I'm going to put the answer back together. So that would be equal to 31 and 5 over 9. Okay. Problem number 3. You have 5 and 3/8 minus 2 and 3/16. So 3/8, 3/16. Yep, I'm going to be okay. All right, so let's go ahead and do the whole part. 5 minus 2 equals 3. So I'm going to put the 3 up here. And then I have 3/8 minus 3/16. So let's do the fractional part. 3 over 8 minus 3 over 16. The LCD for these is 16. So 3 over 8 is now 6 over 16 because 8 goes into 16 twice. 3 over 16 does not change because it was 16, the denominator, 16 denominator now. So 6 minus 3 gives you 3 over 16. So you got your whole part. 5 minus 2 was 3. And you have your fractional part, 3 over 16. Okay. Next one. 23, 8 over 15 minus 8, 3 over 15, 3 over 5. Okay. So let's do the whole part first. So 23 minus 8 would give me 15, right? I'm not going to put that into the answer first until I actually know that I'm not going to have to borrow or add something to this digit. I kind of ballparked it on number 3, so I knew I didn't have to do that. But normally, don't be too quick to put the whole part answer into your answer box. So let's go ahead and look at 8/15 minus 3 over 5. So the LCD for both is going to be 15. So the 8 over 15 will not change because the old denominator was 15, the new denominator is 15, so we have 8 over 15. But 3 over 5, so the 3 over 5 now has to be over 15. 5 goes on into 15 3 times, so you have 9 over 15 minus 9 over 15. Okay. So 8 minus 9, you cannot take 9 from 8. Okay? So that means that we need to go and borrow one more digit from the whole part. Okay? So I'm going to take 1 from 15. So my whole part is now 14. And that 1 is going to be that 1. So actually, no, that's not what I'm going to do. I'm going to borrow that point from 23. Okay, because that 23 and 815 was the first number. So I'm going to take that digit away from 23. So instead of 23, I now have 22. So 22, because I want to take this one digit and put it in front of here. 1 and 815 minus 3 over 5. Okay. We're still not changing the second fraction, but we got the first fraction because we don't have enough, and we can't have a negative fraction. Okay. So 1 and 815. So let's go ahead and change that 1 and 815 into the improper fraction. So that's going to be 15 plus 8 is 23 over 15. And now I am free to subtract. 23 minus 9 gives you 4. So you have 4 over 15 for a fractional answer. So 22 minus 8 is 14. You have your whole part answer as 14, and you have your fractional answer as 4 over 15. 14 and 4 over 15. Borrowing happens not very frequently, but unfortunately it does. So we have to borrow a digit, and then we have to rework the problem using the improper fraction like we did here in instead of the 8 over 15, we borrowed that digit, change that into improper fraction of 23 over 15, and then we can subtract. All right. That concludes our recording for lesson 4.6.